Hello everyone. So welcome to the first webinar of the TTC webinars AWS Primer series of this year, of course. So as you already know, we have already done 16 session, and this is our 17th session. Jyoti, maybe this is our 18th session. Correct me if I am wrong.
This is 18th session.
Sorry, I just sorry for my mistake. Yeah. So in the 70th session, we had already discussed about AWS ELB, and now I will hand it over to Jyoti for today's agenda and another learnings and other things as well. Jyoti, over to you.
Okay, thank you, Faiz, and Happy New Year, everyone. So, this is our part 2 of ELB. So, the part 1 we did, which was 17 series on ELB. So, wherein we talked about what do we mean by elastic load balancer and their type. And today we'll cover another type of ELB, which is network load balancer. So we'll study what it is and lab on the same topic. So let's get started. So since we are meeting a gap after a gap of 2 weeks, so let's quickly revise what we studied in our previous session, because this session is a continuation of our previous session. Okay. So yeah. Let me just press it. Yeah. So in previous session, we understood that why do we need a elastic load balancer? So the ELB helps us to forward our traffic to multiple servers. Okay. And here we have a concept of target group, listeners, rules, etc. So your target group consists of targets, and those targets could be your container, could be your IP address, could be your EC2 instance or a Lambda service. Okay. Then we just okay. Yeah. So we also understood that how does ELB forwards the traffic to the server. So before forwarding the traffic, okay, it has to see whether that instance or your container or your Lambda service, whatever it is it healthy or not? Okay. And we have got various kinds of a health check. Okay. So it could be simple response, okay, which gets returned from a healthy EC2 instance. So if you see a response as 200, that means yes, the traffic can be forwarded to that target. Okay. Or it could be based on how much time you are going to wait until you get a response. Okay. Also you'll see you just in the first instance, like, okay, where you hit a target to see whether it's healthy or not. So first instance you got a success, right? But we will wait for another successive response. Okay. Success response before sending the traffic. Okay. So all these things we studied in our health check. Okay. Then there are three types. In fact, they have added one more, which is gateway load balancer, which I'm yet to explore. So once I'll explore it, I'll share it with you guys. So now when you log into AWS Management Console, you'll see application load balancer, network load balancer, and a gateway load balancer. Okay. So what is your application load balancer? So this load balancer, it works at layer 7. Okay, which is the application layer of your OSI model. So in next upcoming slides, I've taken a small snippet of OSI model to tell you what actually happens at layer 7 and what happens at layer 4. Now your network load balancer, it is for layer 4. Okay. And so in short, whenever you have HTTP or HTTPS kind of a application, you'll go for application load balancer. But when it's TCP or UDP, that time you can use NLB, okay, which is your network load balancer. So when we talk about application load balancer, this is what all you do, right? Remember the practical we did, what we did, we had a debit server and we had a credit server. Okay, debit server target group were there to serve the traffic which was coming for the debit, and then there was we had set up servers for the credit card as well. Okay, so we saw that we had set up a path parameter. So we said if the URL contains credit, then my target server is going to be here. Okay, so when we say our path contains credit, so we are going to send the traffic to these target group. Okay, and if the path contains debit, we are going to send the traffic to the debit card target group. Okay, so with application load balancer, the kind of rule you can have rule based on the values in the query parameter, or you can have rules based on the kind of the HTTP method, whether it's a get or a post. Okay, then path, I told you already, it could be based on the path parameter as well. Okay. Yeah. Right. So here, these are the things based on which you can set rules, right? And also how does he here also, when we talk about the target groups, now target group consists of multiple targets, right? So in this target also, how the traffic would go, it depends upon various routing algorithm. So it could be round robin, okay, or it could be least outstanding request, okay. So there are various routing algorithm based on which the traffic is sent on to the specific target in a target group. Okay. Now today we'll study about, which is our today's topic, which is network load balancer. Okay. So yeah. So we did a recap of elastic load balancer. Now we'll have a quick glance at OSI model, then a little difference about between layer 4 and layer 7 load balancer, and then a small lab. So this is about this session. In next session, we'll continue with again ELB, but we'll understand how do we send traffic across different VPCs. Okay, so how do you do a load balancing between different VPC? We'll do that, and also we'll study how we can use a combination of NLB and ALB. Okay, so in upcoming slide you'll understand that with network load balancer you can get a static IP. Okay, so we can use that in combination of application load balancer. Okay, so these two labs I'll be covering in the next session. Okay, so yeah, so we know OSI model, this is our reference model. It consists of 7 layers. Okay, so example, this is my source device, right? Remember when we were studying about the networking, so what we understood that what exactly is network? It's like devices which are communicating with each other. Okay, so this is my source having IP address as 10.0.0.5. okay, and I want to access something which is placed in this location 10.0.0.3, and the port number which on which I want to access is 80. Okay, so you see when the first call which we are making, okay, here we have all the information. We have the HTTP header. So whenever you do google.com, it in turns get converted into a get request. Okay, and that get request would have headers, it would have content type, etc. Okay, so now based on these content you can forward your traffic. Okay, so this is your layer 7. Okay, so when we say application load balancer, it works at this layer. It helps in managing the traffic at this layer, and here you know all the information. See, you have everything about the you know everything about the request. Okay, then you have layer 6 and 5. So 6 is for encryption, 5, it's kind of establishing a connection between, okay, session between your source and destination. Okay, then finally you have layer 4. Okay, so your network load balancer, it works at this layer where you know the port number and the IP address. Okay, so if you have the port number and IP address, NLB helps you to send that traffic. Okay, and then it's simply at layer number 3 you have more details. your information gets converted into segment, and then at lower level it's into further frames, and finally at the physical layer you are transmitting in the forms of zeros and ones. Okay, so your application load balancer is working at this layer. Okay, and your network load balancer, it's work at this layer. So for this layer what you need is the port and the IP address. Okay, yeah, so here is a small difference between the two load balancer. Okay, see the same thing which we were studying. L4 load balancing offers traffic management of transaction at the network protocol layer. Okay, so I hope you understand what is the difference between TCP and UDP. So here in TCP, if your application follows a TCP protocol for sending the information, so this is more reliable, because it ensures that uh, if a certain packet gets lost, okay, so it does a retry. Okay, but in case of UDP, you don't have that kind of a handshake. It's a kind of a connection less protocol. Okay, so I heard a very interesting example around this TCP and UDP. So understand, TCP protocol is you're thirsty and you're drinking water from a bottle. Okay, so you know the source and you know the destination, and there is an acknowledgement. But if you're talking about UDP, it's like somebody is just pouring water on you. Okay, so it's you are getting water all over your face, but you are getting to drink as well. Okay, and in case you miss, you cannot retry in case of a UDP. So UDP protocols, they're used for your live streaming, etc. Okay, wherein you don't need a acknowledgement. Yeah, so L4 load balancing delivers traffic with limited network information with, yeah, so same thing like in L4, when we are talking about network load balancer, the routing algorithm would be round robin. Okay. And then when we talk about L7, okay, which is layer 7 load balancer, this work at the highest level. And since it is at the highest level, the routing is based on the headers. It could be based on the headers. It could be based on the content of the message, the type of the URL, okay, and the cookies. Okay, and in L4, you just focus on two things, which is your IP and your port number. Okay. Yeah. Now ELB also, it is like two kind. One is like your internet facing, and another one is internal. Okay. So if your ELB is internet facing, I'll show you in the management console as well. So if it's internet facing, that means you have a public IP address. Okay, DNS name is publicly resolvable to the public IP of the nodes. Okay, and can route traffic from clients to your nodes. Okay, but the internal facing, you can, a simple difference if you want to understand, internet facing is like, okay, kind of a public subnet, okay, where you know your nodes IP address, etc. I mean your DNS is directly able to resolve to the public IP of the node. Remember, every EC2 instance which we create, it has got two IPs. One is public and another one is private. Okay, so in case of internet facing ELB, you know the public IP address of the node. Okay, and in case of internal ELB, here DNS server resolves the DNS name of your load balancer to the private IP address of the load balancer. Okay. So the example which I was talking about, which I'll be covering in the next session, wherein we'll use a combination of network load balancer, which would be our internet facing, and then you'll have an application load balancer, which would be my internal ELB. Okay. So there you will understand the difference between these two terms more. Okay. Yeah. So coming over to the network load balancer. So we've studied this again and again, that it's layer 4. And this is used when would you usually one prefers application load balancer. But the scenario where you can pick network load balancer is when there is a lot of traffic. Like this is designed to handle traffic as it grows. Okay. And also with network load balancer, you can get a static IP address of your NLB. So where is these things important? For example, mm, uh, your application, the client who is trying to access the application, the server. Okay, there is certain firewall setup, right? So you want to bypass that firewall, or you want to tell the firewall that okay, if there is a request coming from a particular IP address, I should allow, right? So there you can use NLP, so because you have the static IP address. Okay, and even if, for example, your NLB it gets corrupted, you can create a new network load balancer and then again associate a static IP address. Okay. Yeah. So we'll understand this again. Theory can be a little confusing, but now let's do a practical. Okay. Which would help you to understand network load balancer in more detail. So this is what we are going to do is, first we'll create two servers. One, for example, it is going to serve the traffic for debit card. Another one, it is going to serve the traffic for credit card. Okay, and you'll have your network load balancer, right? So now in what will we do, right? We'll take the DNS of NLP. Okay, and we'll hit in the URL. So you'll see that just by changing the port, if I'll say port 80, okay, we'll get response from the debit card. And when I'll say port 8080, I'll get a response from the credit card. Okay, so we'll do same steps which we did for creating a EC2 instance, which we did while working on application load balancer, which is, okay, we'll create a EC2 instance and we'll have a HTTPD server in both the EC2 instance. But one small change we have to do, that for the credit card server, we need to make a changes to the httpd.config file, and we'll ask that instead of listening on port 80, please listen on port 8080. Okay, so let's get started. If you want, you can practice along with me, right? So what I was trying, I had set up this already for myself.
Okay.
So yeah, I'll show you. I'll do all the steps one by one, but the thing which I was trying to tell you, that with NLB, it's everything about your port, right? Okay, wait. Just a second, Faz, let me reshare. Any doubt on the theory part, Faz, till now?
No doubt.
Okay. My screen got. Yeah, so this is the DNS of my network load balancer. So see, when I do this, you get a response from debit server, right? Because by default the port is 80. Okay, when you don't specify the port, it is port 80. But when I say 8080, see, you see a response from the credit server, right? And in case of application load balancer, remember we were not specifying the port, but what we were saying something like credit
Specific
dot
URL. Yes.
Yes. So that's the difference. If on a high level you want to understand, so application load balancer is all about what request you are sending. Okay, so whatever, so based on your, whether it's a get, post, specific kind of a header or specific content, so based on those things you are able to balance the traffic on various target group. Okay, but in case of NLB, it's, you know, the IP address, you know the port number. So that's why your network load balancers, they are fast. Okay, they can handle multiple connection requests. Okay.
Yes.
Yeah. So let's get started. So first thing what we'll do is we'll launch two instances. Okay. And let me share that user data step in the chat. So in one, make sure you have it as debit, and in second instance which you launch, have it as credit. Okay.
Yes.
Yeah. So I'll also create, I'll go to instance, launcher instance. select the first one, Amazon Linux 2 AMI, configure instance. Yeah, so under user data, you can paste the content and write whatever information you want to write. This is for debit server transaction, anything, just to distinguish between the two requests. Nothing in the storage. Yes, in tag. So since it's for debit, we'll say DB server. Yeah. Now this is important. We are playing with the port, right? So we
Yes.
here in the security group now only port 22 is open. So we have to open port 80 because for debit the port for which we are setting the rule is port 80. Okay. So here go ahead and do port 80. Yeah, review and launch. You can pick any existing key if you have. So I had an LB key for me. Okay. Now since this is launching, I'll go ahead and create another one.
Yes.
In this, enable port 8080. Okay.
Yes.
Nothing in this storage. Yes. Or let me do it CD only. That's fine. If you have Git Bash with you on your system, Faiz, using Git Bash also you can connect to these instances. You don't have to go through putty. So I
Okay.
can, yeah, I'll show you how you can do it. Okay, because we have to log into the credit card server and we have to make changes to the config file of HTTPD.
Yes.
Okay. Let it, okay, it's started. Okay. So what you have to do, Faz, is go to your Git Bash, okay,
Okay.
and go to location where you have downloaded your .tem key.
PEM file. Yes.
Yes, yes, okay. Oh, I should exit this. Okay. So mine is in the downloads. Okay. Make sure you give it the right permission. Remember chmod 400 and then the uh, key name. Okay. So you have to
Okay.
give, yeah, you have to give the right permission. Once you have given that permission, how do you give it? Chmod.
Yeah. Jyoti, sorry to interrupt, but I think your entire screen is not shared. So if
Oh,
you are
yeah, yeah,
typing
yeah,
on the
yeah.
Git bash, it's not
Yes,
visible.
yes, 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 yes. Now, can you see the Git bash?
Yes. Yes.
Okay. So go to the downloads folder where your PEM file is present. Give it the right permission. Okay. So
Yes.
I'll do chmod 400 and nlb. Okay. Now I have given the permission. Okay. So what you have to do is simple SSH I, your key name, EC2 user at the rate, and the public IP address. Okay.
Okay.
So you don't have to go through putty and all those steps. Okay. Yeah. So we are logged in, right?
Yes.
Okay. Now what do you do? Log in as a root. So for that, do sudo su.
Okay.
Okay. Now go to cd etc httpd. Okay.
Okay.
There is this conf. Okay. Then again do cd conf.
Okay.
ls. Yeah. So this file you can do vi or nano, whatever editor you have. httpd. Okay. So if you come down, you'll see it's listening at port 80. Okay.
Yes. Yes.
We'll go ahead and change this to port 8080. Okay.
Okay.
Okay. So I hope you know how to work on VI. So just press
Yes.
insert. Yeah. Yeah. What did I do? 8080. Yeah. Okay. Now, since you've made changes to the configuration file, you just need to restart the server. So how do you do? How do you restart? Service, systemctl or service, both would work. So do
Okay.
service httpd. This is the name of our service. Restart.
Okay.
Okay. Now this has restarted. Okay. Now I'll show you what. Now if you go to your browser, take the public IP address of your credit server only. Okay.
Okay.
And do 8080. Okay. Oh, maybe I didn't paste anything here. Okay, that's fine. It's not showing the text which it was supposed to show, but should be okay with me. And if you go to your debit server and do port 80, yeah, you see a response like this is for debit
Yes.
server transaction. Okay.
Yes. Yes.
Now, yeah. So now my both these two targets are working fine. Now I need to create a target group. Okay. So for this example, we are just adding one target to a target group, but usually there could be multiple targets in a target group. So when there will be multiple targets in a target group, then the traffic, okay, would be distributed based on various routing algorithms. Okay, it could be based on round robin, or it could be the one I said, least outstanding request. Okay.
Okay.
Yeah. And I was just going through their AWS reInvent video. So in case of application load balancer FAS earlier, they didn't had a concept of weight. I mean, distributing the traffic based on the weight, right? So it was either it would go to a target group or it won't go to a target group. For example, if I say /debit, okay, so either it would go to the debit target group or it won't, right? But
Okay.
now they have a mechanism by which you can say my 30% of a traffic should go to a certain target group and 70% should go to a separate target group. Okay.
Okay.
So if you have a concept of a blue-green deployment, right? So blue-green deployment is, it's a kind of, okay, how do I explain you? So it's like, at a time there will be two servers which you will be having. Okay. So what you do, that one server would be active and another server would be inactive. Okay. So for example, currently version of your code which is in the production is say v1.1. Okay. So now both of them are having v1.1, v1.1. Okay. Now I want to go to v1.2. Okay. So what I'll do is I'll add that latest code to the inactive server, and then I'll mark that as active, and the one which was active, I'll make it inactive. So what happens is, in case of any issue, production issue, you can turn to your inactive server.
Yes, yes.
Okay. Yeah. So that is like, okay, you blue server and green server. So now you can say, okay, I want to deploy my code, or if my traffic is coming. So you can say, okay, I am doing some work. So please give 30% of my traffic onto the server A for now. Okay. And eventually you can increase it.
Okay. Okay. Understood.
Yeah. Okay, so now we are done with creating the targets. So let's create a target group. Okay, so I'll go ahead and create a target group. So it's instance. Okay. Yeah. So here my protocol is TCP, because remember our network load balancer, it works on TCP and UDP.
Yes.
Yeah. And you can name it anything. So I'm naming it as DBT. Okay. So this is for debit. So I'm going to select my DB server, port 80. That's fine. Create target group. Okay. Similarly, I'm going to create it for my credit. CDT. Here, protocol is again TCP protocol. 8080. Yeah. 80. By showing 8079. Okay, I have to check. It should be. Anyways. Yeah. Let me know once you are done with creating the target group. I'm checking something.
Yes, sure.
Make sure for credit target group, the port is 8080. Okay.
Okay.
Yeah, mine, I have to update it.
Would it be because you already have one 8080?
No, that is
In
for a
that case,
different,
yeah,
that,
that case, then DBT and DGDB also have the same
yeah,
80.
they are different servers. I'll create again. Never mind. I think it populated on its own, I believe. I have to check. 8080.
Okay.
Yeah. Include as pending. Yeah. So we've created the target groups, right?
Yes. Yes.
Yes. Now comes the important part. But we'll quickly revise the application load balancer also. Okay.
Okay.
So though we have to do a demo on NLB, but for now, for example, let's go to the create load balancer and look at what options we have in application load balancer. When we say create, okay, see, so this is what I was telling you, whether it's an internet facing or an internal. Okay, so
Yes.
internet facing is, it's like you can say front end part, like, okay, client is accessing your application using the DNS, which is of your load balancer. Okay.
Yes. Yes.
And after load balancer, when you want to further have another load balancer, okay, so that is your internal load balancer, right?
Yes.
Yeah. Or in short, see, internet facing load balancer routes request from client over the internet. Okay, so everything is happening through internet,
Yes,
right?
exposed to the internet, and
Correct.
this would be
And the
like,
intern, yes. So here the client request from client to the target using private IP address. So here your client can be again a load ELB only. Okay.
yes, yes,
Yeah. So see, we had to specify so many things here. The security group. Did you see in case of NLB? Okay, we haven't gone there. Okay. So in case of NLB, FAS, we don't have a concept of security group. Why? Because we know the port number and we know the IP address. Okay.
okay,
We cannot filter. So filtering can't be done in NLB. But whereas in application load balancer, you have to do the filtering. You can add further rules on your load balancer. Okay. What kind
okay,
of a traffic you are going to allow, or what kind of traffic you're not going to allow, right? So hence NLB can be used in a situation wherein you want a static IP address. You cannot filter, but you know your application or your client knows that the static IP address is this, right?
yes,
Uh-huh. And then wait, let me just randomly create something because I wanted to tell you a few more things here. ALB2, okay. Yes. So in case of what do you do? Okay, wait here. I'll tell you in the rules part. Okay. Oh, okay. I think this I have to do some settings. But in short, uh, apart from the kind of action you can have in ELB fast, you can either forward your traffic, okay, or you
yes,
can redirect. So there is a concept of redirect as well. Okay, there are, wait, let me just Google it.
okay,
Actions in ELB. Yes. So this is what I was saying. Either you can forward your traffic, okay? You can forward your
yes,
request to a specified target, or you can redirect request from one URL to another, okay?
okay,
So somebody has given an example. For example, you move from HTTP to HTTPS, okay? And when you see a request from for port 80, okay? So then you can do a redirect to port for 443, okay? So even those kind of thing you can do it with the help of your elastic load balancer,
okay,
okay? Yeah. So let's go ahead and create our network load balancer. So click on create load balancer, select network load balancer, create. You can name it anything. So I'm naming it as NLBTTC. This is my internet facing IPv4 VPC. For now, select all the regions. Okay. Now here we have to add two listeners. First, if you are getting a request at port 80, so please send the traffic to my which target group, to my debit
debit,
server. Yes. And if you see a TCP request for port 8080, then you need to send the traffic to which one? The credit card.
credit, yes,
Yes. And we are done with our load balancer. Okay. Right now it's provisioning, so we will wait until it is active.
okay,
Mhm. Okay, so meanwhile it's getting up, we can quickly revise whatever we have studied till now. Okay, so just to ensure that we follow both ALB and NLB. So I'll just
Yes.
go through 17th and 18th slide, just a quick review. Okay. Yeah. So first is like why do we want to load balance? Okay. So this is to see elastic load balancer. It helps us to distribute your incoming traffic across multiple targets. Okay. And how would it distribute? Again, there are rules and all, but it checks for the health of the target. Okay. So this also ensures that your system is highly available. Okay, right? Now your targets could be container, IP address, AWS Lambda, or your EC2 instance. Okay. Now what ELB does is it monitors the health of its registered target and routes traffic only to the healthy target, right? Expose single point of access to your application. Okay, so what do we mean by this? If anybody wants to access your application, whenever I do google.com, it would be mapped to the load balancer, right? And now
Yes.
load balancer would take care of distributing the traffic. Okay.
Yes.
Yeah, it ensures stickiness with cookies. What we mean by this is, with the help of elastic load balancer, you can ensure that your traffic is always routed to a particular server, right? Okay. Then it has got integration with various services, so various services of AWS. Okay. Yeah, and work with configuration using UI. So even you would have seen now with the example that whatever setup we had to do first for ELB, whether it was application or whether it was network load balancer, we did it through the UI only. Okay, there was
Yes.
no programming requirement, though we can set up using CLI, CDK, etc. But setup is very easy, right?
Yes.
Yeah. So health check, it's an important thing for us to know that this is used by AWS to determine the availability of registered EC2 instance. Okay, whether it's ready to receive the traffic or not, right? Yeah. Then type. So now you don't see classic load balancers. Okay, these were like old versions. Okay, when we had EC2 classic, okay, that time we had a classic load balancer. It used to work for both layer 7 and layer 4, but now you have seen on the console that we are seeing three, but that includes application, network, and gateway load balancer. Okay. Now, when we talk about application load balancer, it helps you in routing the traffic based on the information like host name, your path, your query string parameter, your HTTP method, HTTP headers. Okay. And whether it's application load balancer or it's NLB, both of them have a concept of listener, rule, target group. Okay, both have these things common, but your ALB is used for serving traffic for HTTP and HTTPS, but your NLB is for TCP and UDP protocol. Okay. Yeah. Yeah, this is what I told you, that NLB,
Yes.
IP address, and the port. Okay. And use cases is real-time data streaming services or your non-HTTP protocol. Okay. So this is the example which we did in our previous connect, wherein we had created rules. So we had, remember, we had this: if path contains debit, then go here, right? But
Yes.
in network load balancer, you would have seen we just added a rule for the port. Okay, if it's port 80, go here. If it's port 8080, go to this target. Okay.
Yes.
Yeah. Uh, so same thing here. Yeah. So extra thing what we studied is just a overview of our OSI model. If you want to understand this in detail, so you can go to this site, okay? And this person, in fact, he has a YouTube channel also, so where he has explained this in a really nice manner. So I took this slide from there. Okay. So here you can understand that when we say layer 7, so in layer 7, whenever we say google.com, behind the scene it is getting converted to a get request, and then it has got headers and content type, etc. So using that information only you are able to send your traffic. Okay. And then all these you have layer 7, sorry, layer 6 for encryption. Okay. In fact, all the encryption decryption part also can be offloaded to your load balancer. Okay. Instead of having all these encryption, decryption or certificate resolve part, we are not giving that responsibility to your nodes, your web servers, but all these things are taken care by your load balancer itself. So see, your load balancer, apart from distributing the traffic based upon the health of your target, it is helping you in encryption, decryption, all those things as well. Okay. Yeah. So this we have studied, internal and internet facing, and today's example. So let's go and see if we are able to see the difference. Okay.
Yes.
Let's see if it's active. Yeah, it's active. Now take this DNS. So when we don't specify any port, it's port 80. Okay. So if this would come up in few minutes, but yes, if you don't see any response, right, that means you have to check whether your target is healthy or not. Okay. Yeah. So see, this is going to the debit server, right?
Yes.
Now let me do 8080. It should go to my
Credit server.
yes. Yeah, it would be up.
So because we have just created it, that's why it's taking this much time, right?
Yes,
Otherwise,
yes.
it won't take this
Yeah,
much.
yeah, correct. Yeah. Okay.
Yes.
Yeah. So this is what I had for today. But yes, I'll tell you how to delete all those things. In last session, I forgot to mention. Okay. So first thing what you have to do is you have to first delete the load balancer. Okay.
Okay.
Yeah. So I'll delete both of them together. Then you have to delete your target group and then your target. Okay.
Okay.
Yeah. So just check your billing fares. If last time you won't have deleted it, you might be getting some billing.
No, I had deleted.
Oh, you deleted. Okay, okay, okay. Yeah. Now you can go ahead and terminate your instances. Yeah. So this is it, fares for today. In next session, now both the example, they were fairly simple, but it was for us to make us understand the difference between both of these two. Now we know the difference. We know how basic setup needs to be done. Now we can go to some complex demos. So next session would be our final session on ELB, but we'll do 2-3 labs, good,
Okay.
interesting labs, okay, which would cover a real use case, okay, real time use cases.
Okay. Okay. Yeah, thank you, Jyoti, for this. So thank you for the recap also. So you, it was more easier to catch up with the current session and the previous session as well.
Mhm.
And yeah, this was simple, but as you said, in the next lab we will see. Means in the next session we will see some real time lab, and we won't get any difficulties now because we have now practiced these simple labs. So thank you for
Yeah.
that, Jyoti.
Okay. Okay, Faiz. Thank you.
Yeah. Thank you. So see you all next Saturday. Just one update. Now the time has been changed to the 4 p.m. IST. That's GMT plus 5:30. So if you want to attend this session live, now the timing will be accordingly. Or you can follow the test chat and you can get the updates about the timing and other things also. Yeah. Thank you, everyone.
Okay. Thank you, everyone. Bye.